Hi everybody, welcome to another video on Algebra, section 1.7, linear inequalities and absolute values inequalities. Before we go to the inequalities, let's go over the interval notation. So we write an open interval using the parentheses between two numbers is equal to x, such that x is greater than a and less than b. So this set builder notation means the right hand side equation here means, I'm just going to spell it out, the set of all x such that x is between a and b. So when we use parentheses, we mean an open, and there's not including, meaning there's no equal sign. Not including a and b, meaning they don't have the equal sign here. So parentheses is not equal. Right. For the closed interval, we use the square bracket, and it has the equal sign. So the bracket will have the equal sign, and that will be including the endpoints here. And we also have the infinite interval, where we say from a to infinity, from a to infinity including a, and negative infinity to b, and negative infinity to b including b. Notice that we will never include infinity because we cannot never get to infinity. So always use parentheses for infinity, and whether we have the bracket or the parentheses at a number, that means we include or not include the point. Right. And we can also use graph to represent an interval. Right. So the first one, this one, we have a bracket at a and parentheses as b, meaning that on the a we have the equal sign, and we say it is the set of all the x such that x is between a and b including a. And if we draw the graph, just use the bracket at a in parentheses at b. Some other books can also use, for this one, some other books we can also use a solid dot at a and an open circle at b. So they have the same notation. So we can, when there's the equal sign, use the square bracket or solid dot. Where there's no equal sign, use the parentheses and an open circle. So those two are equivalent. Right. Next, just going to this to make a table easier to read. Right. So here we have between a and b, bracket on b, so including b. So we set up on the x such that x between a and b including b. So we go from a to b, and that including b. Right. Negative infinity to a. So we'll write the setup on the x such that, by the way, because everything is greater than negative infinity, we do not need to we don't need to write it's greater than negative infinity. A. We do not need to write this because that is a given. Everything is greater than infinity. So in that case, we just say x less than a, and we go from a to negative infinity. So we're just gonna have that, and not including a, so the parentheses, negative infinity. And then here from b to infinity, likewise everything is less than infinity, so we do not need to write. So we have b including, we do not need to write less than infinity because everything is less than infinity. However, we can write just b less than equal to x, or x greater than equal to b. Notice that the b still get the pointy end of the inequality, so it's still like that. So go from b to infinity, including bracket, and here from negative infinity to infinity, we just say the set of all real numbers. We just say x is a real number. If we want to write set builder notation, so the set of all the x such that x is a real number. This symbol means is in, so x is in the set of rational numbers. So because everything is greater than infinity and less than infinity, so in this case we're going to draw the whole line. And just to, I forgot to mention that for an empty set, we're just going to draw the line that we do not select anything on the line for an empty set. Right, so that different type of notations, and we're going to use those notations to write the answer for inequalities. Right, inequalities in one variable. Linear inequalities are in one of those forms. So we have greater than or equal to, less than or equal to. And all the properties for solving linear equation. So add something on both sides, subtract something on both sides, multiply or divide something on both sides will be the same, except when we multiply or divide by a negative number, only by negative number, we have to reverse inequality. Right, so those are the things that we need to watch out for. The rest is just like solving linear equation. By the way, when we say linear, we mean that there is no quadratic or any higher. It's just a power of x, and then just x and a constant. Right, now here we solve for this inequality. So try to get x by itself, just like we solving with the solving equation. So subtract 3 on both sides, we have negative 2x less than 8, and then we divide by negative 2 on both sides. And note that since we divide by the negative number, we have to reverse inequality. So from less than to greater than, and this gives us x greater than 8 divided by negative 2 is negative 4. So x is greater than negative 4. So if we're going to draw the solution, because we only need negative 4, right? It is greater than negative 4. So it's greater than negative 4 will be on the right side. and greater than not including, there's no equal sign, so we use the parentheses. Or in the interval notation, we write from -4 to infinity. Right, so just like equation, except for this rule, multiply or divide by a negative number, we need to reverse inequality. Right, so that's that. Same thing here. Try to get x by itself. Subtract x plus 4 so that gives us -3x on the left side, and then greater than or equal to 9, and divide -3 on both sides. Once again, since we divide by a negative number, inequality here must be reversed to less than or equal to. That gives us x less than or equal to 9 divided by -3 is -3. So if x less than or equal to -3, so on the graph we have -3 and x less than that. So it's going to be on the left side because it's less than. So greater than the number on the right, less than on the left. Or in interval notation, -infinity to -3, but this time it has equal sign, so we have to bracket. Right, just like that. Now, if we can multiply, if we can divide both sides, we can also multiply. So here multiply on both sides by something that can eliminate the denominator. So I will multiply by the least common denominator of 4 and 3. So a number that is both divisible by 4 and both divisible by 3, that could be 12. So multiply 12 on both sides of the equation. So multiply by 12. So when we do that, 12 and 4 cancel out, there's 3 left. So we have 3 x plus 3 greater than or equal to 12 and 3, that will be 4. Notice that because we multiply by a positive number, we do not reverse inequality. We only reverse inequality when we multiply or divide by a negative number. So that's just 3. Right, now multiply it out. 2x plus 9 greater than or equal to 4x minus 8 plus 3. So that gives us 3x plus 9 greater than or equal to 4x minus 5. Now once again, move everything on one side. So that gives us -x. That cancel out, that cancel out. Greater than or equal to -14. And then finally divide by -1. Once again, it is a negative number. So this inequality is reversed. And negative divided by negative is positive. So it's 14, and it's less than, so it's on the right, on the left, less than on the left. It has equal sign, so the bracket. So we say from -infinity to 14, including 14. Right. Here, same thing multiplied out, we have 2x plus 8 greater than 2x plus 3. And once again, we try to move x to one side. So subtract to negative 2x and minus 8. That cancel out. And we have 0 greater than negative 8 plus 3 is negative 5. Notice what we have here is 0 greater than negative 5. This is true for every x. Meaning, doesn't matter what x is, it is always true. So the solution is all real numbers. Or if we're going to draw the line, it will be a solid line. Or we write negative infinity to infinity, or we can just say all real numbers. And because x, it doesn't matter what x is. The equation is always, the inequality is always true. Right, look at this one. Once again, try to move everything on one side. So that cancels, we have 0 less than or equal to negative 9. Now 0 less than negative 9, this one false. 0 is greater than negative 9. When it's less than, it's false. For every x, because it doesn't matter what x is, it will never work. So we have no solution. We use an empty set or just a line where we do not say anything on it. Alright, so just like solving the equation, except when we multiply or divide by a negative number, we reverse inequality, and just need to know how to write the notation, the solution in the different notation. Right. Next, solving compound inequalities. Negative 3 less than 2x plus 1 and 2x plus 1 less than or equal to 3. So when we put this together, we have 2x plus 1 between negative 3 and 3. And to solve for that, we can just subtract 1, try to get the x by itself. Negative 4 less than 2x less than 2, and then we divide by 2 on both sides. By both sides I mean everywhere. Divide by positive number, no need to reverse inequality. By that I mean don't reverse inequality. So here we have x between negative 2 and 1. It's not including between negative 2 and 1. Right. Okay. Right. Now we go to absolute values inequality. Recall absolute values inequality. Absolute values is a distance from a number to 0. Right. So let's say we have where c is positive. So we have 0 in the middle. And we have c and negative c. About 3.5. About that. So let's say we have c here, negative c and c. So recall that where we have absolute values of u equal to a, where a is greater than or equal to 0, then we have u equal to a or u equal to negative a. Right. So that is when it is equal to. What happens if we have greater than or less than? Now, so when it is equal to, for example, if we're talking about u equal to a number c, then that will be equal to negative c or c. When we have equal to, we have those 2 points. Now we have greater than and less than. Now think about it. Absolute values is distance. If absolute values is greater than something, meaning the distance is greater than something, right? Once again, absolute values is distance. If it is greater than, the distance is greater than. Now what is the distance actually measure from? So remember, absolute value is distant to 0. So let's say if it's less than some number, that means the distance to 0 have to be less than. So in which case we have this scenario. So when it's equal to, it will be the 2 points, but when it's less than, it will be in the middle. Why is that? Let's say you have a number that is less than c. So where we have a point, let's say a point here, the distance from that point to 0 is less than the distance from c to 0, right? So that's why when it's less than, the distance have to be less than, and the distance to 0 is less than, meaning it have to be in between. In between. Let's put this. So absolute values is where we have the endpoint. When it's less than, it will be in the middle because the distance is less than. Now, if the distance to 0 is greater than c, meaning it have to be further away from 0 than c. So it could be over here, over there. So when it's greater than, it will be on this side, or on this side. So when we have less than, it is in between, and when it's greater than, it is on the outside. Okay, less than, in between, greater than, on the outside, equal to the boundary, the 2 points. Alright, so we have different scenarios here. Like I said, just think about that in terms of distance. If the distance to 0 is greater than a number, it have to be further away from the point. So it have to be on the outside. So the distance to 0 is bigger than c. Right. But all of that have to be for c greater than 0. When c equal to 0 or less than 0, you cannot use this. Have to just use common sense in that case. Right, now let's look at this problem. So when we solve this problem, just try to isolate the absolute values first, and then we have these 2 scenarios. So here we have absolute values already, and it's less than 3. Remember, this one less than 3. So that means it have to be between negative 3 and 3. I don't write the answer like that yet. So we just have inside the absolute values, it's going to be between negative 3 and 3. No equal sign here, so that's just what we have. And now we just add 4 on both sides. By that I mean everywhere. We have x in the middle, 7 on the right hand side, and 1 on the left hand side. So we have between 1 and 7. So between 1 and 7. And no equal sign, so that's parentheses. So that's what we have. Right. Go to the next one. Just like the previous problem, try to get the absolute values by itself first, and then we can determine the rest. First, put the plus 1 on both sides. So we have -2 times absolute values of x plus 3 less than or equal to, that will be -4. Right. Now divide by -2 on both sides. So when we divide by negative number, keep in mind that this inequality must be reversed. And that is -4 divided by -2 is going to be 2. Positive 2. So that's what we have. Now, this is greater than. So greater than meaning it will be on the outside. On the outside of 2 and -2. So greater than 2, less than -2. So when we have absolute value of x plus 3 greater than 2, so we're going to write, just going to start over here, x plus 3 greater than or equal to a positive number, or x plus 3 less than -2. So when it is greater than, we're going to have greater than the positive, less than negative. By the way, it works because we have a positive number here. Right? Now we just solve for x. So we have x greater than or equal to -1, or x less than or equal to -5. So outside of -1 and -5, right? So just draw a line. Now, because -5 is less than -1, so make sure we put this in the right order first. And then next, we have less than -5. So when we draw this, the answer should be on the outside. And this one has the equal sign, so that will be a bracket. Let's say some book use the brackets, some using the dot, the solid dot for equal sign, and the empty circle when there's no equal sign. Right, so we just said -infinity to -5 bracket, -1 to infinity. What we do in that case, when we have two interval, we're going to use the U, which stands for union, which means in here or in there. Because it's two intervals, so it could be on this interval or that interval. The union meaning can be here or there or both, but it cannot be both. So, well, pretty much means or. Right, now we have 7 less than absolute value of 5 minus 2x. I noticed that, of course, we can always rewrite the inequality. So I prefer to have the absolute values on the right hand side. I mean, the left hand side. So the 7 still got the pointy end of the inequality. So if we write 7 on the right, it will still get the pointy end. Right. Now this one is greater than it's going to be on the outside. So we will write 5 minus 2x. It's going to be greater than 7 will be on this side, or 5 minus 2x less than negative 7 will be on that side. And then minus 5 on both sides. And then divide by negative 2. And once again, reverse inequality. So we have x less than negative 1. Right. Same thing on the other side. When it's less than negative 7, set negative 2x less than negative 12. And divide by negative 2. Once again, reverse inequality. X greater than 6. So we know the problem is greater than, so the answer must be 2 intervals on the outside, and in particular in the outside of negative 1 and 6. So be outside 6. And this one, no equal sign, so parentheses. So when we see the problem that is greater than, the answer is going to be outside. Less than, it's going to be in the inside, in between. Right, so we write negative infinity to negative 1, not including 6 to infinity, not including 6, and once again, union of the two intervals. Right. Right. Notice that we can only do that when in between or on the outside when the number is positive. So what happened when the negative numbers like this? Of course, I did mention when something like that happened, we have to use common sense. So negative 1, and on the right side we have absolute values. We have properties that says absolute values is a distance. That definition, a distance cannot be negative. Distance, and a distance is greater than or equal to 0, cannot be negative. So the left hand side cannot be negative. The right hand side is negative. So that means this is always greater than, the left side is always greater than the right hand side. Right? 0 is greater than negative number. Positive is greater than negative. So this one is true for every x. So in that case, doesn't matter what x is, it is always the solution. So we just said the solution is all real numbers. I should just select the whole line pretty much. Or in interval notation, for all real numbers we just use the set of real numbers, or So that is the solution. Right. Likewise, once again, absolute values is a distance, and the distance cannot be negative. And so we have a number that is cannot be negative, less than negative 4. Think about that. Cannot be negative, meaning either 0 or positive. Now, if we have 0 less than negative 4, that could be false. If we have positive less than negative 4, so that also false. So this one is false for every x. If it's false for every x, there's no solutions. So we just draw a line and we not say anything, or we use the empty set as a notation for no solution. Right. So once again, a distance cannot be negative, meaning it can be either 0 or positive. And in that case, 0 or positive cannot be less than or negative 4, so there's no solution. Right. Last one. Once again, we do not have a positive on the right hand side. That means we have to use common sense. If there's a positive on the right hand side, this will apply, and we can solve for it. Less than, in between, greater than, on the outside, equal to the 2 points. Right. Now, once again, absolute values x plus 2 less than or equal to 0. So absolute values, once again, that is the distance, and the distance cannot be negative. So I just said it's going to be equal to a positive number, or it's going to be 0. Right, distance can be 0, but cannot be negative. Right, now think about this. If we put positive in here, positive less than or equal to 0, that will not work, right? Positive do not greater than equal to 0, so positive doesn't work here. Now, if we put 0 in absolute values, 0 less than or equal to 0, which is true. So the only case that works here is that absolute values x plus 2 has to be equal to 0, because that is the only chance for this inequality to work. If it is greater than 0, positive do not positive is not less than or equal to 0, so positive in here, that would be false. If you have 0 there, 0 less than or equal to 0, so it's good. I could say it. Yeah. So in this case we have x plus 2. Actually, just say equal to in this case, because that's all we have. Now, if it is equal to, in the equation is a little bit slightly different than the inequality. If it is equal to 0, distance to 0 is either that equal to 0 or equal to negative 0. Was negative 0 is still 0, so we don't really have that. So absolute value is equal to 0, meaning it has to be equal to 0, and that's the only option. Right, of course, that's the same thing. Subtract negative 2 on both sides. So if x equal to 2. So if we write the solution interval notation, actually it's just 1 point. Or if it is not an interval, so the solution, the x equal to 2, or we say the solution set is, negative 2. X equal to negative 2, or just a point, or going to be just negative 2. Right. So when we don't have a positive number on the right hand side, absolute values it's a distance cannot be negative, so we just use a common sense and do the reasoning. In that case, it could be all real numbers, no solution, or could be a point, or could be different scenarios. But we cannot use those formula if we have a negative number or if we have zero. It have to be different case by case. With that, we finish section 1.7. Thank you for watching, and see you in another video in college algebra.